All right, if you've spent any time working with SSIS, you know how incredibly powerful it is. But you also know that gut-wrenching feeling when a tiny, temporary glitch, like a missing file or a network hiccup, just brings your entire ETL process to a screeching halt. Well, today, we're going to fix that. We're going to build a solution to make our packages way smarter and a whole lot more resilient.
Oh yeah, we've all been there, right? You've got a package, it starts to copy a file or maybe connect to a web service, but it just isn't available at that exact nanosecond. And what happens? The whole job fails. It's such a common problem, and it can be so incredibly disruptive. So what's the answer? Forget about using external schedulers or clunky workarounds. We're going to build a really robust and intelligent retry mechanism right inside our SSIS package. You'll see it's way more efficient, it's totally self-contained, and honestly, it's surprisingly simple once you see the pattern.
You know, the heart of the problem really lies with what I call these fragile tasks. Just think about a simple file system task. Its job is easy, but it is 100% dependent on something outside of its control, a file sitting on a network share somewhere. If that file is delayed for any reason, a network blip, another process running long, the task fails. And by default, it takes the whole package down with it.
Now, you might be thinking, hey, wait a minute. Doesn't SQL Server Agent already have a retry option in the job step? And you're right, it does. But, and this is a big but, it has one massive limitation that makes it completely the wrong tool for this kind of problem. Let's break down why our custom approach is just so much better. The difference here is simple, but it is absolutely profound. The SQL Server Agent Retry, it's a blunt instrument. It restarts the entire package right from the very beginning. Imagine a process that takes an hour to run. That's so wasteful. Our custom approach, on the other hand, is surgical. It isolates and retries only the one single task that failed. It's just way, way more efficient.
So how do we actually build this thing? Well, we're going to create what I like to call a little retry machine right inside our control flow, and we're going to do it using just a few standard SSIS components. The heart of this machine is going to be a for-loop container and a handful of key variables that tell it exactly what to do. These three variables right here are the brains of the whole operation. First, you've got I. That's just our simple counter. It ticks up with each attempt. Then you have retry count. This is the magic number where we define our limit. Let's say we want to try 5 times. This makes our whole solution super easy to configure later. And finally, there's until success. Think of this as our on-off switch. Once the task finally works, we'll flip this to true, and that tells the loop to stop. All right, let's get our hands dirty and actually build it. The logic really just breaks down into 3 main parts: setting up the loop itself, defining what happens when things go right, the success path, and defining what happens when they go wrong, the failure path. Okay, step 1 is the loop container. We drag one onto the control flow, and we need to configure 2 key expressions. The init expression just starts our counter I at 0, but the real logic, the real secret sauce, is in the eval expression. This tells the loop to keep running only if 2 things are true. We haven't gone past our retry limit, and our success flag is still false. Now for the easy part. You just take that fragile task, your file system task, your web service call, whatever it is, and you just drag and drop it right inside the for loop container. That's it. We've just tucked our task inside its own little safety net. Next up, we have to tell it what to do on success. So we connect the task's green success arrow to an expression task. This new task has one and only one job: to set our @until_success variable to true. This basically acts as our eject button. The second that flag gets flipped, the loop's condition becomes false, and it stops running. Job done. Now for the other side of the coin, the failure path. This is what makes the whole retry magic actually happen. We're going to drag a red failure arrow from our task over to an execute SQL task. Why? Because we need a way to pause between our attempts, right? We don't want to just hammer a resource that's not ready. And that pause is created with this one simple line of T-SQL, wait for delay. In this case, we're waiting for 5 seconds, but you could make this value whatever you want. It could even be driven by another variable. After this little wait, the loop finishes its current cycle and gets ready to try the main task all over again. So, we've built the logic. Now let's see this thing in action. Let's imagine our package runs, but the file it needs, well, it's not there on the first try. The package kicks off. The loop starts its very first iteration. The file system task runs, but nope, the file isn't there, so the task fails. But here's the cool part. Instead of the whole package turning red and crashing, the execution just calmly follows that failure path we created.
Our execute SQL task now kicks in, and that wait for delay command runs. The package just pauses gracefully for 5 seconds. This is that breathing room we wanted. It's giving that external resource, that file, time to show up.
After the delay, the loop starts its second iteration. And this time, let's say the file has appeared. The file system task runs, it finds the file, and success! Execution now follows our green success path. Our until success flag gets set to true, and the loop exits cleanly. The rest of the package can now continue on its merry way.
Now, everything we've just built is perfect, but it will absolutely not work without changing one single critical property. I'm serious, if you forget this step, the whole mechanism will fail on the very first error, and you'll be pulling your hair out wondering why. So here's the catch. By default, any container in SSIS, and that includes our for loop, has a property that basically says, hey, if any task inside of me fails, I'm going to fail too. And that default behavior would completely torpedo our retry logic because the loop itself would just give up after that very first failed attempt. This entire pattern hinges on changing one property on the for loop container itself. It's called MaximumErrorCount. By default, its value is set to 1. That means the loop is only allowed to see one error before it fails itself.
To make this all work, you have to increase this value. A really good practice is to set it to be the same as your @retryCount variable. What this does is it tells the container, hey, it's okay. I expect the task inside to fail a few times. Just stay alive and let our retry logic do its job. This one single setting is the key that unlocks this entire powerful pattern.
And there you have it, a robust, totally configurable, and surgically targeted retry mechanism, all built entirely within SSIS using standard components. So the question I want to leave you with is this. Think about your own ETL processes. What other fragile tasks, calling APIs, accessing FTP sites, running external programs, could this amazing little safety net protect?